this question, we have to find the coefficient of x square in the expansion. The coefficient of x square is given as 3. We have to find the value of the constant a. So in the expansion of 1 plus x upon 2 whole square, what the first thing we should know is that for the coefficient of x square, when we expand this, we need a constant term over here. Not a constant term, we need a term in the power of x, which when multiplied by this will give us x squared, and a term in x squared, which will multiply by 4 to give us a term in x squared again, and they will simplify to give the coefficient of x square as 3. So for the expansion of 1 plus x upon 2 to the power 6, for the coefficient of x square, we'll write 6c2, b to the power, which is b is x upon 2 to the power 2. So we know that 6c2 is 15, and this will become x square upon 4. And for the coefficient of x, we'll get 6c1 x upon 2 to the power 1. So this will become 6 upon 2, which is 3x. So we'll write 4 plus ax multiplied by 3x plus 15x square upon 4. Now multiplying 4 by 15x square upon 4, we will get 15x squared, and 3x multiplied by ax will give us 3ax squared. And this will be equal to 3x squared. So taking x squared common, we'll get 15 plus 3a is equals to 3. So a will be 3 minus 15. 3a will be 3 minus 3 minus 15. So a will be 3 minus 15 minus 12 upon 3. So the value of a is minus 4. Question 2, we have a point which is the midpoint of the line joining the points 3, 7, and 1 minus 1. We have to find the equation of the line through M, which is parallel to the line x upon 3 plus y upon 2 equals to 1. So basically this means that we have 2 points 3 and 7 and 1 and minus 1. M is the midpoint through which the line is passing, and it is parallel to another line which has an equation x upon 3 plus y upon 2 equals to 1. Now as the lines are parallel, we know that the gradients are equal, and this line is passing to the point M. To find the equation, we need a point and the gradient of the line. So we know that the point is M, which is a midpoint. To find the midpoint, we'll use a formula x2 plus x1 upon 2. So this will become 3 minus 1 upon 2, comma 7 plus 1 upon 3. So the midpoint or the coordinates of M will be 2 upon 2, which is 1, and 8 upon 2, which is 4. For the gradient of the line, we know that the gradients are equal. So the gradient of the line x upon 3 plus y upon 2 will be, so taking the LCM, we get 2x plus 3y is equals to 6. As the LCM is 6, so 6 times 1 is 6. Making y a subject, we get y is equals to minus 2x plus 6 upon 3. So we know that the gradient of the line is minus 2 upon 3, which means that the gradient of this line is also minus 2 upon 3. So we have the gradient and the point. To form the equation, we know that the formula is y minus y1 is equals to m into x minus x1. The y coordinate is 4. The gradient is minus 2 upon 3 into x minus 1. Now we can leave the equation in this form as well, or we can simplify it, which will become 3y minus 12 is equals to minus 2x plus 2. Simplifying this, we get 3y is equals to minus 2x plus 2 plus 12, which will be plus 14. In have a curve which has a gradient dy dx k upon root x, where k is a constant. The points P and Q lie on the line. We have to find the equation of the curve. To find the equation of the curve, we'll integrate the gradient, which is dy dx. We can write this as kx to the power minus 1 upon 2. Now integrating this, we get y is equals to k. We increase the power by 1, divide by the new power which will be positive half, plus c. So our equation is y is equals to 2kx to the power 1 upon 2 plus c. Now to find the value of k and c, which are constants, we have 2 points on the curve which are 1 comma minus 1 and 4 comma 4. So first substituting point p, which is 1 comma minus 1, we get minus 1 is equals to 2k times 1 plus c. So this will be our first equation. Substituting point q, which is 4 comma 4, we get 4 is equals to 2k times 4 power 1 upon 2 plus c. So square root of 4 is 2. So we have 4 is equals to 4k plus c, which is our second equation. Solving the two equations simultaneously, we get, so 2k plus c is equals to minus 1 and 4k plus c is equals to 4. So we get minus 2k is equals to minus 5, which means k is equals to positive 5 upon 2. And substituting the value of k 5 upon 2 into any one of the two equations, we get c is equals to minus 1 minus 5, which is minus 6. So the equation of the curve would be y is equals to, so it is k upon 2k root x plus c. So 2 times 5 upon 2, 5 upon 2 into root x plus, so c is minus 6, so we get minus 6. So the final equation would become y is equals to 5 root x minus 6. In question 4, we have a diagram which shows a circle with center O and radius r. Points A and B lie on the circle and angle AOB is equals to 2 theta. We have to express the perimeter of the shaded region in terms of r and theta. So first we know that the perimeter of the shaded region consists of the line AT, BT and the arc AB. So we can write that perimeter is equals to arc AB plus the line AT plus the line BT. So the arc length is given by S is equals to r theta. So the radius is r and theta is 2 theta. So we can write it as 2 r theta. Now for the length of AT and BT, we can divide this into two equal parts. We know that the tangent makes a right angle with the radius and this angle is theta. So the length AT could be written as tan theta is equals to opposite, which is AT upon r. So AT is equals to r tan theta. As AT and BT are equal, so r tan theta plus r tan theta, this will become 2r theta plus 2r tan theta. And then part 2, we have to find the area of the shaded region and the values of r and theta are given. Now the area of the shaded region consists of this part. So if we can find the area of the sector and subtract the area of the two triangles, we'll get the area of the shaded region. So we know that this length is r tan theta. So the area of this triangle would be half into r tan theta. So we can write that the area of the shaded region is equals to area of two triangles minus area of arc AOB. Now we know that the area of the triangle would be half into r, which is 5, into r tan theta. So this will be 5 tan of 1.2. We have to make sure that our calculator is in radian mode, minus the area of a sector is given by half r square theta. So simplifying this, we'll get 25 tan 1.2 minus half into r square is 25, and the theta is 2 theta, so this will become 2.4. As this is 2 theta and theta is 1.2, so 2 into 1.2 will make it 2.4. Substituting these values in the calculator, we get 64.3. 25 tan 1.2 minus this will become 30. So the area of the shaded region is 34.3 centimeters squared. In question 5, we have a solid cone with a slant height of 15 and a vertical height of h. We have to show that the volume of a cone is given by 1 upon 3 pi 225 h minus h cube. So we know that the volume of the cube is given, which is 1 upon 3 pi r square h. Now, in the given expression, it does not contain r, so we have to find h in terms of r. Now, let's say this is r and this is h. So we can say that 15 square is equals to 8 square plus r squared, which means r squared is equals to 15 square is 225 minus 8 squared. Substituting the value in the formula, we have 15 into pi 1 upon 3 into pi into r square, which is 225 minus 8 square multiplied by h. Expanding the bracket, we get 1 upon 3 pi into 225 h minus h cube. In part 2, it says that given that h can vary, find the value of h for v has a stationary value. So stationary value basically means that the dv by dh would be equals to 0. Now we know that v is equals to 1 upon 3 pi into 225h minus h cube. And for the stationary value, we'll find dv by dh and put it equals to 0. So differentiating this, 1 upon 3 pi will remain as it is a constant. This will become 225 minus 3h square. Now substituting 0 over here, we'll get 0 is equals to 1 upon 3 pi into 225 minus 3h square. So the 3 will multiply by 0 and the pi will divide by 0 will give us 225 minus 3h square is equals to 0. So h square is 225 divided by 3, which is 75, which means h is equals to square root of 75. For the nature of the stationary value, we'll differentiate the function again. So differentiating the function again, we get d square v upon dh square, which is equals to, so 1 upon 3 pi will again remain as it is. The 225 will become a 0. And differentiating minus 3h square, we get minus 6h. Substituting square root of 75 over here, we'll get 1 upon 3 pi into minus 6 into square root of 75. Now, as we have a negative value, we know that the double derivative will be less than 0, which means that this will be a maximum point. In question 6, it is given that x is greater than 0. We have to find two values of smallest values of x for which 3 tan 2x plus 1 is equals to 1. So 3 tan 2x plus 1 can be written as tan of 2x plus 1 is equals to 1 upon 3. Tan inverse of 1 upon 3 will give us the basic angle, which is 0.322 in terms of radians. Now we know that tan is positive in the first and the third quadrant, so we'll make the basic angle 0.322 in the first quadrant and 0.322 in the third quadrant. So our angles would be 2x plus 1 is equals to 0.322 as we take our angle anti-clockwise from the positive x-axis. Pi plus 0.322, as it is 2x, so we'll add 2 pi to both our answers. So this will become 2 pi plus 0.322 and 2 pi plus 0.322. But as it says, we have to find the two smallest values of x. So what we'll do is we'll write 2x plus 1 is equals to 0.322. So this will become x is equals to 0.322 minus 1 upon 2. Now this will give us a negative answer, and as x has to be greater than 0, so this answer will be cancelled out. Our other two solutions would be pi plus 0.322 minus 1 divided by 2 and 2 pi plus 0.322 minus 1 divided by 2. Substituting these values in the calculator, we get x is equals to 1.232, comma 2.80. As we have to give our answer in three significant figures, so the final answer will be x is equals to 1.23 and 2.80. In part B, we have a function f of x which is 3 cos squared minus 2 sine squared of x. We have to express f of x in the form a cos squared x plus b. So we know that sine squared is 1 minus cos squared. So we can write 3 cos squared x minus 2 into 1 minus cos squared x. Expanding and simplifying, we get 3 cos squared x minus 2 plus 2 cos squared x, which will become 5 cos squared x minus 2. Now in part 2, we have to find the range of f. To find the range of f, it is better to use a graph as it easily tells us what is the maximum minimum value. Now if you draw a graph of cos of x or y is equals to 5 cos of x, so let's say this is 5 and this is minus 5, a graph would be drawn like this. Now, because of the squared sign, the negative values become positive and the graph is drawn like this. So if it was just a graph of y is equals to 5 cos squared of x, our maximum value would be 5 and our minimum value would be 0. But the function f of x is 5 cos squared x minus 2, which means the graph of f of x of 5 cos squared x would be shifted 2 units downwards. The point 5 would be shifted to 0.3 and this lowest point, which is at 0, will be shifted to minus 2. So f of x, the minimum value of f of x would be minus 2 and the maximum value would be 3. In question A, we have an athlete that prepares to run for marathon by increasing the distance she runs each day by 1.2 kilometers. So we know that as the distances are increasing equally, it is an arithmetic progression and the common difference is 1.2. On the first day, she runs 13 kilometers, which means that the value of A is 13. We have to find the distance she runs on the last day of the 21-day period. So we know that the nth term for an AP is A plus n minus 1 into D. As A is 13 and n is 21, so this will become 21 minus 1, 20 times 1.2. So the 21st term would be 37. In part 2, we have to find the total distance she runs in the 21-day period. We know that the formula for sum is n upon 2 times 2a plus n minus 1 into d. So n is 21, a is 13. 21 minus 1 will become 20 times the common difference, which is 1.2. Substituting these values into the calculator, we get the sum for 21 days, which is 525 kilometers. In part 3, it says that the first, second, and third terms of a geometric progression are x, x minus 3, and x minus 5. We have to find the value of x. For geometric progression, we know that the common ratio r is given by the second term divided by the first term, or the third term divided by the second term, or any two consecutive terms. When we divide, we get the common ratio. So we can say that the second term, which is x minus 3, upon the first term, x is the common ratio, which will be equal to the third term, which is x minus 5 divided by the second term, which is x minus 3. Cross multiplying, we get x squared minus 5x is equals to x minus 3 whole squared. Expanding x minus 3 whole squared, we get x squared minus 6x plus 9. X squared and x squared will cancel out. So minus 5x plus x will plus 6x will be x is equals to 9. So the value of x is 9. In part 2, we have to find the fourth term of the progression. So for a GP, the nth term is given by AR power n minus 1. We know that x is equals to 9, which is also the first term. So A is equals to 9. And the common ratio is x minus 3 upon x. So 9 minus 3 is 6 upon 9. And as it is a fourth term, so 4 minus 1 will become 3. Substituting this in the calculator, we get 9 times 6 cube upon 9 cube, which is equals to 2.67. For sum to infinity, the formula is a divided by 1 minus r. So a is 9 divided by 1 minus, and the common ratio was 6 upon 9 or 2 upon 3. So we get 9 upon 3 minus 2 upon 3. So this will become 27. In question 9, functions f and g are defined by f of x is 2x squared plus 8x plus 1, g of x is 2x minus k. We have to find the value of k for which the line is the tangent to the curve. So tangent means that they are intersecting at one point. So first we'll equate the two equations. Simplifying this, we get 2x squared plus 8x minus 2x, which is 6, and plus 1 plus k is equals to 0. Now, whenever we have an unknown constant in our quadratic equation, we use the discriminant, which is b squared minus 4ac, to find the value of the unknown constant. And as it is only one point of intersection, this will be equals to 0. So in our equation, a is 2, the coefficient of x squared, the value of b is 6, which is the coefficient of x, and the constant term is 1 plus k. Substituting these values in the discriminant, we get 6 squared minus 4 times 2 times 1 plus k equals to 0. Expanding this, we get 36 minus 8 minus 8k equals to 0. So 8k will be is equals to 28. K is equals to 28 upon 8, which is 7 upon 2, or 3 wholes 1 upon 2. In part 2, it says in the case where k equals to minus 9, find the set of values of f of x less than g of x. So we know that f of x is 2x squared plus 8x plus 1, and g of x is 2x plus k. So minus minus will make it a plus 9. So this is 2x minus k. So 2x minus minus 9 will make it a 2x plus 9. Simplifying this, we get 2x squared plus 8x minus 2x, which is plus 6x, plus 1 minus 9 will make it a minus 8 less than 0. We can divide the whole equation by 2 to make it x squared plus 3x minus 4 less than 0. Factorizing this, we'll get x squared plus 4x minus 4 less than 0. So the two values of x are x equals to 1 and x equals to minus 4. Now to get the correct inequality sign, we can first draw the x-axis. We know that this point is -4 and this point is +1. As it is less than 0, basically this is the region where the graph is negative or less than 0. So we know that the value of x has to be greater than -4 and x is less than 1. In part 3, it says in the case where k equals to -1, find g inverse of f of x. So first to find g inverse, we know that g of x will be 2x minus k. So minus minus will make it a +1. To find an inverse function, we first write y in place of the function g of x. We replace the value of y with x and the value of x with y. Making y our subject, we get y is equals to x minus 1 upon 2. So this is g inverse of x. Now to find g inverse of f of x, in place of x, we will substitute the function f. So g inverse of f of x will get, in place of x, the function f is 2x squared plus 8x plus 1 minus 1 upon 2. So 1 and 1 will cancel out. Dividing 2 by 2x squared and 8x, we'll get g inverse of f of x is equals to x squared plus 4x. So we can write x squared plus 4x is equals to 0. Taking x common, we'll get x plus 4. So the two values of x are x equals to 0 and x equals to -4. In part 4, we have to express 2x plus a whole square plus b. So the easiest way of converting into this form is, first we can expand this expression, which will become 2 into x squared plus 2ax plus a squared plus b. Simplifying this will become 2x squared plus 4ax plus 2a squared plus b. Now to find the values of a and b, we can compare this with the original function f of x, which is 2x squared plus 8x plus 1. So the coefficient of x on the left hand side is 4a and on the right hand side it is 8. So 4a is equals to 8, a is equals to 2. The constant term is 2a squared plus b and on the right hand side it is 1. We know that the value of a is 2, so 2 squared 4 times 2 is 8. So 8 plus b equals to 1. So b is equals to -7. So we know that f of x can be written as 2x plus 2 whole squared minus 7. Now this is the full square or the completed square form, which tells us that -2, -7 are the coordinates of the turning points. So the least value of the function is -7. In question 4, we have a curve which has equation 1 -4 upon 2x plus 1 whole square. It intersects the x-axis at a. And the normal to the curve at a intersects the y-axis at b. We have, in the first part, we have to obtain expressions for dy dx and integral of y. So to find the dy dx, it is better to first bring the function x plus 1 whole square in the numerator, which will become -2, x plus 1 to the power -2. Now differentiating this, 1 will become 0, -2 times -4 will become a +8, x plus 1, and the power will decrease by 1, which will become a -3. And as this is a 2x, this will multiply by 2, so the final answer will become 16 upon 2x plus 1 whole cube. For the integral of y, again we'll write it as 4 into 2x plus 1 to the power -2. Integrating 1, we get x. Integrating this function, we'll get 2x plus 1. The power will increase by 1 and it will divide by -1 and multiplied by the derivative of the function, which will become 2. So the final answer will be x plus 4 upon 2 will become 2. 2 into 2x plus 1 to the power minus 1. Or we can write it as x plus 2 upon 2x plus 1. In part 2, it says find the coordinates of B. Now we know that the normal to the curve at A intersects the y-axis at B. So the equation is y is equals to 1 minus 4 upon 2x plus 1 whole squared. We know that A is the point which is on the x-axis. So at this point, the y-coordinate will be 0. So we can substitute 0 over here to get the coordinates of A. So this will become 4 upon 2x plus 1 whole squared is equals to 1. Cross multiplying, we will get 4 is equals to 2x plus 1 whole squared. Taking square root on both the sides, this will become 2 is equals to 2x plus 1. So x is equals to 1 upon 2. So the coordinates of A are 1 upon 2 comma 0. Now first we'll find the gradient at point A, and then we'll take the negative reciprocal as B is on the normal at A. So dy dx at point A will be, we know that the dy dx is 16 upon 2x plus 1 whole cube. So this will become 16 upon 2 into half plus 1 whole cube. So 2 and half will make it 1. So 1 plus 1 is 2. So 16 divided by 8 is 2. So the gradient of the tangent at A is 2. The gradient of the normal will be minus 2. Minus 1 upon 2, the negative reciprocal. Now, to find the coordinates of B, first we can form the equation of the normal. We have the point A and the gradient, which is minus half. So the equation will be y minus 0 is equals to minus half into x minus half, which is the x coordinate of A. And now to find the coordinates of B, we know that B lies on the y-axis, which means x equals to 0. So substituting x into this equation, we'll get y is equals to minus half times minus half, which will be plus 1 upon 4. So the coordinates of B will be 0, comma 1 upon 4. In part 3, we have to find the area of the shaded region. Now we know that the shaded region, basically, we can first find the total area of the curve, under the curve, and then the area of the triangle. So this point is half and this point is 1 upon 4. So the area of the triangle would be half into base, which is 1 upon 2, into height, which is 1 upon 4, which will be equals to 1 upon 16. So the shaded area consists of the triangle and the area under the curve. For the area under the curve, you have already integrated in the first part. So the integrated form was x plus 2 upon 2x plus 1. The limits will be half and 0. So substituting half into the equation, we will get half plus 2 upon 2 into half plus 1 minus, substituting 0 into the equation, we'll get 0 plus 2 upon 1. So 1 upon 2 plus 2 upon 2, 1 upon 2 plus 2 upon 2, which is 1, minus 2 upon 1, which is 2. So 3 upon 2 minus 2 is minus half. Now, as we know that the area of the curve was lying beneath the x-axis, we'll get the answer negative. But as area cannot be negative, we know that the area will be positive half. So the area of the triangle, which is 1 upon 16, and the area under the curve, which is 1 upon 2. Simplifying this, we'll get 9 upon 16 as the area, total area of the shaded region.